Would you please make welcome Mr. Gavin Hamilton, the Chief Technology Officer of ASC, to share his insights into the future world of defence. Please make him welcome.
Thank you. I'll get off that photo as quickly as I can, I think. It's around this oval a little bit too much. I'd first like to thank Dassault Systèmes for inviting me here today. It's a particular privilege, I think, to be talking on my home turf here in Adelaide for once. I've often given presentations about PLM, sometimes around the world, in other parts of the country as well. But yeah, it's a real privilege here in Adelaide today. I'm going to just give you a bit of an overview of what I'm going to talk about today. Not everyone in this audience will know who ASC is, so I'm going to tell you who ASC is in a very brief way. I'm going to give you, I guess, an idea of how ASC has gone on a digital journey from the time that it was first created. And I'm going to talk about that in a couple of eras in terms of the build years and the sustainment years. Although noting that the build years and sustainment years for ASC actually overlapped because of a long build of the Collins-class submarine, for example. I'm then going to talk about what the future holds and where ASC is hoping to take things in the future. And most importantly, I think some key messages for people to take away as to the things ASC has learnt along the years of this digital journey. So let's tackle with who is ASC first of all, for those not in the defence world. We are Australia's largest specialised naval defence shipbuilding organisation. So we were established in 1987, I believe it was, to basically create and build the Collins-class submarine. We have a number of long-term contracts, and the first ones I'll talk about are in relation to the Collins-class submarine. So we have an in-service support contract today, which is what we entered into after actually building the submarines. And we also conduct training services for the Royal Australian Navy over at HMAS Stirling in WA. Another contract that we have, which is getting through to completion, only a few years left to run, is actually a Hobart-class air warfare destroyer program. That first ship is actually handed over to the Navy. At the moment, the second ship is undergoing some trials, and the third one is well advanced on its build program. So it's a program that's in the end of its final build cycle. I think it's worthwhile just giving you a bit of an idea of just what a submarine is like in terms of complexity, because I think this puts it in context around the digital journey that ASC had to do in order to manage the enormous amounts of information. Now, I think probably the best one to look at here is probably the Boeing 777. Ignoring the weight and tonnes and that sort of stuff and length in metres. Look at the number of systems. So on a 777 Boeing plane, for example, we have about 40 systems compared to about 108 on a Collins-class submarine. Number of suppliers, 550 versus 1,600. So the supply chain for ASC is quite large for building a Collins-class submarine. Number of parts to assemble, it's about 5 times what a Boeing has. So it's about 500,000, 500,000 compared to 100,000. Number of person hours to assemble, and I think this is the real kicker when you look at this. It's 2.5 million hours to assemble a submarine versus around 50,000 for a Boeing 777. And I think that just shows just how big and complex a submarine is. It also shows how hard work it is. And I think it also shows the complexity of the number of systems that you need to put in a submarine in order for it to be an effective warfighting platform. Construction time as well also varies. You're up to about 5 years on a Collins-class submarine versus about just over a year for a Boeing 777. And a little bit of cost, which is probably a few years ago in terms of its estimate. But yeah, it's about $1 billion to build a submarine versus about $300 million for a Boeing 777. So hopefully that puts it in some context for you. And so I'm going to talk about the build years. And I guess the message I want to give here is that ASC, established in 1987, but actually really started operation probably in 1988, has always been quite a digital organisation. It started up, and it was, I guess, a start-up in terms of building a submarine. It was able to focus on actually exploiting what the current technology of the day was. Now, I'm not going to try and guess the average age of the person of the people in this room, but 1988 was quite a while ago. And the technology of 1988 is far different than what it was today. But even then, ASC in those very early years adopted what was then called MRP2, which is the Manufacturing Resource Planning type software, which is the precursor of the enterprise resource planning systems that you have today. It committed to that, it found a vendor, and it still uses that vendor today in that ERP space. So it's migrated from MRP to ERP. But I think that shows that from the very early days, ASC was committed to actually trying to work in a digital sense. For the young ones in the room, you won't recognise what that computer is. It's actually a Macintosh SE. I'd come out of a telecom at the time, which used to be, is what Telstra is today. And we had dumb terminals on our desks. I went to ASC and we all had these little Macintosh SE computers on our desk. Again, quite progressive, I think, for an organisation to actually roll out Macintosh SEs to everyone. Not cheap, but again, it was showing that ASC was on a digital journey. We did move to IBM PCs in the late 1990s, and we're still running those sort of computers today with the current version of Windows. We also did a lot of bespoke apps. So back in the late 1980s, early 1990s, you couldn't go to a company like Dassault and get a whole bunch of things off the shelf. You had to basically build a lot of things. So we built configuration management systems, document management systems, logistics and cost schedule to help us manage the program. We were into CAD though. So the Collins-class submarine was designed all in CAD, an old CAD system called Medusa, which some will know of here today. Obsolete obviously today, and we've moved it on from those times. We also, though, I guess started that build of Collins in the late 1990s. We started to migrate those 2D drawings across to 3D. So we recognised in the late 1990s that we had to move to 3D at some stage. And we even did, I guess, some investigations and trials into PLM in the late 1990s. Our correspondence, and again, another example, I think, of ASC being very progressive. You wouldn't believe the amount of correspondence that was generated on a defence build program. Imagine those 1,600 suppliers. Everything was in a fax, a memo, or a letter of some sort. Again, ASC, I think quite surprisingly for me at the time, whilst we were using fax machines and letters, we actually went on every bit of incoming and outgoing correspondence, we actually electronically scanned it as well. And that's been a real valuable asset to us as we've moved on into sustainment. I'll talk a little bit about that later. And just lastly, documents. Defence projects do generate lots of documents. And we developed lots of documents in this project. Initially started off on Apple devices, the SEs that we had, stored locally, but eventually as we moved to IBM PCs, we actually put them into the IBM PC network sort of environment that most people would be familiar with today. So that really defines the build sort of program, sort of finished around 2003. As I said, there's an overlap with sustainment. So we had already started sustaining Collins-class submarines by this time. Just moving on quickly, PLM. So in 2006, we started a program of PLM, and it was a strategic program, and I'll talk about that in a minute. We digitised everything. So we scanned and we OCR'd all that information so we could actually search it later on. And all the important information that we had, we put into those systems. We did a data integration layer to help us do some improved reporting. 3D CAD, as I said, we had developed the 3D CAD model, and we're now using that 3D CAD model within our sustainment activities. We're doing a whole bunch of digital working today, so we are exploring what we can or can't do, whether it's photorealistic virtual reality training at the training school, or whether it's virtual design models and also 3D printing. It is a key element for us today as we move forward. And of course, deploying mobiles out into the workforce, and even operational maintenance today is conducted on tablets as opposed to paper. So let's get on to what PLM is today, and I think this one's really important. A very simple statement that defined what PLM was. It's a strategic business approach. So I've heard a few people talk here today. It's not always about the technology, it's partly about the technology, but it's actually absolutely about a strategic business approach. It's about your business. And so we ASC committed to actually managing our products digitally, in a digital form, from the first time we actually thought of it, all the way through to retirement. And that really defines what we did with our PLM program. I'll give you some idea. We're an engineering organisation, so we love to actually put things into functions. So we defined our PLM functions in terms of 6 things: configuration management, program management, product data management, authoring, being the 3D CAD and that whole virtual reality space, Requirements, very important in defence space in terms of meeting what it is that your customer's asking for. And lastly, simulation and modelling, a very important one. I think at the time in 2006 when we were going around the world looking at these sort of systems, simulation and modelling was there, but it wasn't really given the same sort of prominence. And I guess what we've managed to do today is we've managed to bring all those elements together to give ourselves a really good environment in which we can actually sustain and look after Collins. And there's nothing more that tells this than in terms of, I guess, some numbers out of our repository today. And by the way, our PLM system is based upon the Dassault Systèmes Innovia product, or the 3DEXPERIENCE product, as it's now called today. And we now have 8.6 million, or in excess of 8.6 million objects in that database, and there's about 20 million connections. That diagram you see there, you won't be able to look at and understand with any clarity because it's too small, but it gives you a bit of a snapshot of how those things in our database are all connected up. Quite a large repository. And I think this also shows, from a user point of view, we have over 2 million documents checked into that database, including all that correspondence I talked about. And that correspondence, dating back to 1987, can be searched. So the content of those letters and things can be looked at. And I have had occasion in an engineering function of actually having to do that and actually finding documentation in like less than 5 minutes that would have taken me forever if it was still in paper. Most importantly though, 1.1 million files viewed last year. So this system is absolutely a huge success. Our people are using it and they're reaping the benefits from it. And 140,000 new files uploaded last year. Big success, and it's working really well for ASC. I'm a CTO, so I do have to look towards the future, and ASC has been on this journey. And I guess if there's one thing I'm going to say, this journey never ends. Technology is changing, and it always will, I think. So ASC has actually put together a bit of a thought paper. You know, where could we be going? Where are we going to go in the future? And if you take that cloudy sort of picture in the middle, we've broken up our applications into 3 major areas, being program enabling, which might be CAD systems that are very specific to a program that we might execute. Business enabling, which is all about our finance systems, our HR systems and those sort of things. And I guess the other one is all about making sure that it's really our PLM sort of application, the thing that brings all that product data and all that engineering data, all the supply data, everything all together into one spot that we can then leverage the benefits from. You'll then see 5 circles around, and I'll talk about this one first of all. This is that digital twin, and you would have seen some things from Dassault around digital twins. In here we've got our 3D model, we've got our simulation. This is all about in 3D, executing in a digital sense before you actually do it in a physical sense. We see absolutely great promise in exploiting those technologies. And a Collins class, just because it's built, doesn't mean it doesn't undergo design activity, it doesn't mean that it doesn't be advanced. A Collins class submarine still has another 20 odd years to go, and the technology that needs to go on that submarine to keep it contemporary and to keep it useful for the Royal Australian Navy needs to be kept updated. So we're continually doing design changes and capability upgrades to that submarine, and also handling obsolescence. The connected shipyard. So this one's about actually making sure that we bring all that data in. So this is probably a bit of that Industry 4.0 that you'll see. It's about biometric scanning. It's about RFIDs. It's about machinery sensors. It's about making sure that our shipyard operates the most efficiently and effectively it can. It's about making sure that our machines, if they're about to break down, we know before they break down so we can go and do some corrective maintenance on them, for example. Very important element for us. User experience. Well, you know, if these things aren't useful, aren't usable by a user, then they won't get used. And I think we don't do enough of this in the technology world. I think we often create technology for the sake of technology without often looking at how it's going to be used by our users. So we are very mindful about making sure that we supply an environment that is going to be used by our users, but actually understood by our users in an intuitive way such that they don't need to be trained to the nth degree to get the benefit out of it. So that is about mobility, it's about task management, it's about how people can self-service. So you shouldn't need to build up a big IT department that can actually take 2 years to develop a report, for example. Users should be able to get that sort of information out themselves in order to do the jobs. This one I'm really excited about. This is information discovery. I've got a Collins class submarine that's going to be 30, 40, maybe a bit older than that by the time it, years old by the time it actually retires. So we already have people leaving ASC today. They're taking a whole bunch of knowledge with them, and we have a lot of information. So this is one of those areas where I think we can really exploit and leverage very, very usefully. We talk about AI, we talk about artificial intelligence. I think the most promise in the next stages is really around that whole assisted sort of assistant bots, I guess I'll call them. I'm trying to think of the non-technical term. So computers are very good at looking across loads and loads of data and actually bring it into a discrete, very simple form for people to look at. And if you can just imagine that, a design activity that was done 20 years ago, a human trying to find that in amongst those 2 million documents, in amongst those 8.6 million objects and 20 million connections, it's going to be quite hard. But a computer can just do that and start to present information. I think that's really one area that is going to be of real use to us. Analytics as well is another area that we absolutely need to exploit as time goes on. And the last one, not least, is collaboration. As I said, 1,600 suppliers. Wouldn't it be good if you could actually collaborate with those suppliers online? I'll just mention the other thing that's always on my mind. I'm responsible for cybersecurity as well at ASC. Everything I'm talking about here has to always be wrapped up in a defence world around security. I think importantly as well, though, that's no different than any commercial organisation. The intellectual property, the IP that you own as a company is just as important as defence information. I have a whole bunch of rules that I have to follow in order to keep that information safe, but it's just as important for commercial companies to keep IP safe and IP of their suppliers safe in order to ensure you stay in business. So I guess collaboration is going to have to work in order to bring people in your supply chain. It brings your people in your organisation all together in order to basically do designs, to do sustainment, to actually leverage that extended knowledge base that's actually out there in your organisations and in your wider supply chain. A very big one, but it's got to be tempered with the right security and the right mechanisms in place to protect that. So that's really just a view of the future of where ASC is looking at. I'm going to spend a bit of time on key messages because I think this is probably the key thing out of this presentation. If you're going to embark on this journey, commitment. So one thing ASC has absolutely learned is about commitment. I was going to cross out that no because, once you start this, really, you don't want to take no as an option ever. You have to stay committed to this. It's not easy. I have lots of scars. It was not. Putting a PLM program in, for example, was quite tough because we were changing the way ASC did business, and that's really what it's about. It's about actually looking at the ways you can do your business better. What I can tell you, though, if you commit, and you commit strongly, it's all the way from the top of your organisation, all the way down to the bottom. And if you do that, you will be successful, and you will get and reap the benefits that you will expect to get out of this investment that you make. Data quality. When you're an organisation like ASC, we had lots of data. Users told me it was really good data. They lied. I'm sure they thought it was good data, but when you tried to link it up with other pieces of data, it wasn't as good as what I guess they were giving the impression. So you've really got to focus on your data quality and make sure that you get that all right before you start to bring it all together. If you're starting afresh and you're starting from scratch, you can focus on that from day one to make sure you've got the data models and things designed correctly and architected correctly. And I love this one, hard work. It is hard work, but you know what? Hard work really pays off. And if you get this right again, and you work hard at this, you have a vision, you know where you want to be, hard work will actually be and deliver those results that you actually, I guess, are expecting out of your program. I had a really good team. I had really good management that I worked for. Everyone was committed, and everyone worked really, really hard, and we got our payback within 18 months. And it's a journey. It is a journey. But really, you've got to run this as a set of discrete projects. Don't view it as sort of, I'm going to start here and 5 years later I've finished. PLM never finishes. This digital journey never finishes. So what's important about being able to make sure you're on that road when you need to, come back if you need to, take a side road, always assess and evaluate where you're going. It's okay to make mistakes, and it's okay to sort of recognise and accept those mistakes as long as you then move forward from those mistakes. You learn from them, and that's the important thing. And I'm happy to say ASC made lots of mistakes, but gee, it paid off and it was worth it. But the most important thing, and this is about people, it is about the technology, but it's actually more about the people. And I think I can't emphasise this one enough. And when I say people, I also extend your partners in this. So companies like Dassault Systèmes, for example, they're as essential to the success of this program as anything. And you've got to bring everyone along for the ride. You've got to leverage the vendors and their knowledge and their expertise across many, many different projects. But likewise, you've got to bring your people along because your people are your most valuable asset. If you get them on board and you get them going on this, you will reap those benefits and you'll get their buy-in, and maybe life won't be as hard as I'm indicating there in that hard work, but it is absolutely essential. And it is key there about the little things indicating people talking. Because I find that if you get people talking, if you get them collaborating, end of the day, this just falls out at the end of the day. And that's my last slide, and I have 8 seconds left, so I think I've done just about right. My contact details are there. I will be hanging around after the end of this, and I'm more than happy to talk to anyone about this. You might see my passion here. I am very passionate about this. I'm passionate about submarines, and I'm absolutely passionate about technology. I'm passionate about the vendors that supply these sort of products, companies like Dassault, for example. This stuff can really, really work for you, and I know if you commit to it, then you'll get there as well. So I'd like to thank you for your attention, and I'll pass you back to someone else. All right, thank you.